All right, welcome to 5b-3, Solving Radical Inequalities. This one you want to make sure you have some really solid notes on because there's a lot of itty-bitty steps and little details that change your outcome quite a bit. So first off, I want to remind you how to solve radical equations, which is relatively simple. Once you have the square root part all by itself, you can just square both sides to get rid of it. So really, we should put parentheses around that. So what we have is left over, x minus 6 equals 25. Because the square and the square root are inverse operations, those completely undo each other. So what we're left with is just the x minus 6 equals 25. So we're going to add 6 to both sides, and we've got x equals 31. That's all there is to it for an equation. However, if we change that into an inequality, there's something that we need to pay more attention to. Because one of the things that we know is that we're not going to have a single value for x. Once we have an inequality, we're going to have a range. And so when we have ranges for x, we have to know what our minimum, or in some cases maximum, value can be. The way that we're going to figure that out, and we'll take some more notes on this, actually, we'll come back to that. Solving it is going to be generally the same way that we do an equation. We've got x minus 6, drop down our less than or equal to 25. We add 6, and we have x is less than or equal to 31. So if we were to put that on our number line here, we'd have a solid circle, and then everything under, it would help that if I wrote 31 instead of 30, everything under 31 can be a solution. The problem with that is if I have, let's say I've got 0 down here, if I put in 0 minus 6, then what I have would be the square root of 0 minus 6, square root of negative 6. And then we have a negative square root, which we're not dealing in imaginary numbers right now, and we can't do that. So what we're going to do before we start anything else is take this and figure out what our lower boundary is. Because we know if we're going to take the square root of something, it has to be greater than or equal to 0 to remain positive. So what we're going to do is just take that x minus 6, make it greater than or equal to 0, add 6 to both sides, so we know x has to be greater than or equal to 6. So that adds in a boundary at 6 that x cannot go below. So our overall answer here is that x can be between 6 and 31 to make this inequality true and real, including 6 and 31. So that's the part that radical inequalities changes compared to radical equations. And this gets much more complicated when we have x's on one side compared to just numbers. So in our notes here, it's important to note that we can only take the square root of a positive number. So our first step, and please remember this step because it's one that almost at least half of my class keeps forgetting. You're going to find the limits on x by setting what is under the square root sign greater than or equal to 0. And I want to note that the greater than or equal to 0 part has nothing to do with this. This part right here, that's separate. Greater than or equal to 0 is making sure that we keep our square root with a positive underneath it. So we're going to take this x plus 3, nothing else, and we're going to do x plus 3 is greater than or equal to 0 to make sure that we have a positive. I'm going to subtract 3, so I've got x is greater than or equal to negative 3. I am going to put that on my number line. So move this down real quick. Put 0 on here just for reference. And then I'm going to put my -3 and my greater than or equal to. That gives me the first thing that I know about this just because of what's under that square root sign. The next part is just your basic solving. So you're going to take, scoot that down just a bit. Now go back to your original inequality. Square root of x plus 3 is greater than or equal to 2. First thing I want to double check is that the square root part is alone on one side. It is, so now it's okay for me to square both sides. And I'm putting parentheses around this for issues with negatives and knowing what's being squared and so on and so forth. It's just a little bit more precise. So what I'm left with on the right side is x plus 3 is greater than or equal to, and on the right side I have 4. I subtract 3, so I've got x is greater than or equal to 1. I'm going to put that on my number line as well. And when I have a number over here, no x's, just a number, then my solution region is the place where on the number line where it's true for both. So this is only true for our boundary. Once we get here, anything above 1 will work, and including 1, will work in that inequality without causing us any issues. So this part, I'm going to put it... This part here is our final answer. So I've got everything from, in inequality form, x is greater than or equal to 1. In interval form, I have a bracket with 1, comma, infinity. Infinity always has the parentheses next to it. So that's if you have it greater than or equal to, or the inequality sign, and then you have a number. It is a fairly labor-intensive process, and you need to make sure that you put those notes. It gets a bit more complicated when you have an x, but the first step does not change. So the very first step, just like before, we are going to take this x plus 6, and we're going to set it greater than or equal to 0. So I'm not looking at anything else in this problem except for just making sure that under the square root sign stays positive. I'm going to subtract 6 from both sides, so x has to be greater than or equal to -6. It's my first boundary. I want to put that on my number line. And then go back to my original, and of course it wouldn't stay there. Okay, fix that. Okay, so now I got my boundary on my number line there. Now I'm going to solve my actual inequality. So I have square root of x plus 6 is greater than x. And this is going to require some skills that you need from solving quadratics, because what we'll find here is that we have x plus 6, and I'm going to go ahead and replace this with an equal sign right now because all I'm trying to find is my boundaries. If I have an x squared and I have x's, that means I have a full quadratic. And so what I'm going to do is subtract x, subtract 6, so I have this full quadratic of x squared minus x minus 6. I'm going to shrink this down real briefly and solve that quadratic off to the side. You can use quadratic formula. That's x equals -b plus or minus square root b squared minus 4 times a times c, all divided by 2a. You can use that, or you can use factoring. So box and diamond. x squared, negative 6, first and last, multiply those two, negative 6x squared, negative x. Then you're figuring out your factors of 6 that will multiply together to give, factors of 6 that will add together to give you negative 1. That ends up being negative 3x and 2x. Those go in the remaining boxes. And you're looking at greatest common factor for any row or column. I'm just going to look at this row. Most I can take out of there is an x. So I've got x times x gives me x squared, x times 2 gives me 2x, x times negative 3 gives me negative 3x, and then I double check. Negative 3 times 2 is negative 6. That's the quick and dirty of that. If you struggle with that one, you may have to go back, move that to the side, may have to go back a ways and at least go back to the quadratics 5-2 so you're comfortable with how to solve those. So my factored form, x minus 3 times x plus 2, which means my boundaries are 3 and negative 2. And I'm not writing x equals 3 and x equals negative 2. The most I can say right now is they're involved. X is involved with 3 and negative 2 somehow. So I'm going to put those on my number line. And I'm just going to put a squiggle for now. I'm also going to put 0 on there. And then I'll put the 3 on there. And then I need to figure out in this next step how exactly these are involved. So where do the rest of my arrows go? And I'm going to do that by testing a point in this region, and this region. So my original inequality, I lost square root of x plus 6 is greater than x. So I am going to test, I'll do negative 3. In this middle section, I'm going to test 0. And over here, I'm going to test 5. Could be anything in those regions. So just whatever works for you. And you're going to get some unpleasant numbers because of the square roots. So the first one, negative 3 plus 6 is greater than negative 3. So I have the square root of 3 is greater than negative 3. That's like 1.4 or 1.7. I don't remember. Either way, it's a positive number, and it is greater than negative 3. So that one works. In the middle, I have 0. Square root of 0 plus 6 is greater than 0. Square root of 6 is greater than 0. Square root of 6 is 2 point something, which is also greater than 0, so that one does work. The next one, 5 plus 6 is greater than 5. So square root of 11 greater than 5. The square root of 11 is somewhere between 3 and 4. So I've got 3 point something. And I would put that in the calculator, but I don't have my calculator with me because I did not plan ahead. And it is not true that 3 point something is greater than 5. So that one does not work. So what we find here is that the space between, I'll put that in green to show that works. The space between negative 6 all the way up until 3, and I'm going to put an open circle there, and that's because of the open circle on the inequality, so because of that. The negative 6 is the closed circle because that ones are greater than or equal to 0. what works in those tells us our solution region. Down here, when it says we're ruling out extraneous solutions, that goes back to the equations. So that -2 is one of our boundaries that ended up being an extraneous solution, but it works perfectly well in our inequality. So our final answer on this one is -6 to 3 for our interval. And then for our inequality, x is between -6, greater than or equal to -6, and less than 3. So that is that for solving radical inequality. Down carefully so that you know what to do and what not to do when you're on your own with this. So, have a good day.